See, in today's class, I'll try to make you understand how to interface your ultrasonic sensor with number HCSR04 with your Raspberry Pi. What is the purpose of this ultrasonic sensor is it is used to detect any object movement in front of this sensor. Okay, it is also similar to your infrared rays. It is also similar to your PIR sensor, which I took yesterday. The difference between these two is PIR sensor uses infrared rays, a heat related information which is generated from our body or from another animal, and tries to find the distance with that. But if you take ultrasonic sensor now, it uses this ultrasonic waves to find the distance from the sensor to the obstacle. Are you getting me, guys? Shall I repeat this? I will repeat this. PIR sensor, what it does is it uses infrared rays. That is like heat energy which is generated from our body or from the object to identify the particular object from the particular obstacle. From the particular sensor, it will find the exact distance using this heat energy. Okay, they are saying that almost it is not that accurate to use your it is not that accurate to go for high level projects. It doesn't find the distance or the obstacle which comes in front of the PAR sensor that accurately. So the alternate for that is ultrasonic sensor. This uses your ultrasonic waves or your waves to I find the distance from the obstacle to the sensor. Okay, so what are the components required is I need this sensor. I need this 1K resistor 1 and 1.5K resistor 1 to do this exercise, and have I need some jumper wise. Okay, so let me get into this. Let me make this big. Yeah, can you see this, guys? Yes, yes or no?
Yes, sir.
Okay, see, this is how it looks like your HCSR04 sensor. It has four pins basically. First one is your VCC. This VCC pin should be connected to the 5 volts of your GPIO pin. Then next is your trigger. See, trigger is nothing but a positive pulse. Okay, in electronics lab, you might have learned what is a positive pulse. Okay, if the state is high, we call it as a positive pulse. So this trigger basically like this. Let me annotate and show it to you. See here, this is trigger. So this is trigger. Okay, you got this, guys? This is the positive pulse. This is the trigger, we call it as. Okay, echo is nothing but the impact that has after this echo is generated. So it's like this. This is the echo. Okay, it is like an audio signal, guys. Are you getting this? What is a trigger and what is an echo? So a trigger is nothing but a positive signal which is generated from the sensor. This sensor, it should do that. Okay, echo is nothing but the impact after this echo is generated. Okay, you should understand this. What is this basic difference? This is electronic components. Then it will have uh, one more pin which is called as ground pin. This ground pin will be connecting it to the any ground part of your GPIO. Okay. Now, what is the operating voltage of this SR04 is? There is a drawback in this. It accepts only 5 volt DC. Okay, but the operating volt of your Raspberry Pi board is 3.3 volt. So you have to reduce this volt. So how to reduce this voltage? That's why I told you I'm using two resistors. That is 1K and 1.5K resistor to reduce the volt of HC04 sensor 5 volt to 3.3. 3.3 is the default volt accepted by your operating voltage that is accepted by your Raspberry Pi. Are you getting me, guys? Yes or no?
Yes, sir.
Yeah. So next is what else is important? Yeah, measuring angle is 15 degrees. It will accept up to 15 degrees. Okay. So this HC0SR04 sensor basically will have two things, two transducers. The first one we call it as the transmitter, second one we call it as the receiver. So this echo signal will be generated by the transmitter, and it will be sent to the particular obstacle. Okay, obstacle is the sense, obstacle is our animal, okay, or the object which is kept in front of us, or our hand. So that once it reaches the so echo signal, it's a positive signal, it is generated by the transmitter. So once it reaches this obstacle, what happens, so it will be converted to a audio signal, that is an echo signal. Then it will be transmitted back, then it will be transmitted back to the receiver again. Okay, so you have to calculate the speed of the sound here. Okay, from the transmitter to the obstacle, what is the speed of the sound? Okay, what is the distance covered? Okay, that is the major function we are going to do here. Please understand, your PAR sensor uses your heat energy to find the distance. Here, this your HCSR04 sensor, that is your ultrasonic sensor, uses your audio waves or your sound waves to calculate the distance. Okay, this they are saying, since it uses both transmitter and receiver, it is more accurate to find the distance of a moving object from your sensor. Am I clear? Are you getting this? Uh, Guys, please respond. No? Yes.
Yes, sir.
Yes,
Okay.
sir.
Okay.
Yes, sir.
See. Okay. See again. One more drawback is it is accurate up to 4 meters. After this, if you move your hand or your object is above 4 meters, it doesn't give the exact output. So that should be noted here. Okay, let me show the exact part here. See here. Yeah. This is the way it works. I told you already manually, sorry, orally. See, first we have to initiate a positive pulse. Okay, this we call it this we do it through trigger pen. Okay, that we do it for 10 microseconds. So it will be given to the transmitter. From transmitter, it will come here. Okay, it will be converted to an echo pulse, that is an audio signal. Then it will, this is the obstacle, this is the animal or our hand. After coming here, it will bounce back to again receiver. So we have to find the distance between here, see here, from the transmitter to the obstacle and from the obstacle to the receiver. This is the part we have to concentrate. Okay, this is where our sound energy is. This specifies the exact distance between your sensor and your obstacle. Okay, so how this is done, is there any formula for this? I'm not going to get, see here. Okay, this is easier to understand. See, trigger, it's a positive pulse. Once it is given, it is converted to audio signal, we call it as the echo. Okay, how this is done is basically the speed of this sound, no, from your HCSR04 sensor, it is, they are saying it is 344 meter per second. This is the speed it takes normally if you use this sensor. Okay, if you convert that into a centimeter, it is 34400 centimeter. Okay, so uh, the final formula is, what is the general formula? Speed is distance by time. So we have to calculate distance now. So distance is speed into time. So the formula exact is, we have to divide it by 2. Okay, distance is speed into time. So speed is 2x. See here, speed is 2x. From here, the echo is traveling, the sound signal is traveling, and again it is bouncing back. So this is 1x, this is 2x. So what we are doing is, from the total thing, that is 34,400, we have to reduce it by 2. So if you reduce it, we are divided by 2. If you divided it by 2, we get it as 17150 into the time. Time is the system time, okay, or the time which it takes for the traveling from the transmitter to the obstacle and from the obstacle to the receiver. Okay, so this is a default function available in your Python, which calculates the time taken for the sound to travel from the sensor to the obstacle and obstacle to the receiver. So this should be multiplied with this speed. Speed is of the sound is 17150. I told you how it is 17150. That is 34300 divided by 2. Are you getting this, guys? Or,
Yes, sir.
yeah, are you getting this? Yes, I made my best to make you understand in IT way. Yeah, your electronics, oh, it might be okay. Let me go to the circuit part. Now, how to do this connection? Yeah, this connection part is visible to you? Yes or no? Guys, please respond. No?
Yes, sir.
Okay,
Yes, sir.
so connect this HCSR04 sensor into uh, your breadboard. See here, this VCC. This VCC, I am connecting it to the. See, this is red color wire. I'm connecting it in series with the. What is the pin number? 1, 2, 3, 4. So fourth pin, you have to find it out. What is fourth pin? Do you remember? Fourth pin is 5 volt, right? Yeah,
Yes, sir.
yeah. Fourth pin is 5 volt. So I'm. This is not operating voltage. It is the normal voltage. Operating voltage is 3 volt. One point I forgot to tell, you should always remember that transfer operating voltage is 3.3 volt. Always better to keep it in 3.3 volt. Okay. Okay, let me come back here. Go back to the circuit. Okay. Where is my trigger pin? Second pin is my trigger pin. That trigger pin, I have connected it in series with this blue jumper wire. This blue jumper wire, it's connected to the 40th pin. 40th pin of your GPU IO. What is your 40th pin? It should be an IO pin. So let's check it out. Yeah, it is GPIO. So it's an input and output pin. It's GPIO 21. Okay. Let me come back here. Let's understand two more wires. What is my third pin? This is echo. See here, this trigger pin that doesn't require any conversion because we are giving the input from the GPIO to the trigger pin. Please understand, through the program. Through the program, I am giving an input to this trigger pin. So it doesn't require any voltage conversion. But if you take echo, no, echo, it is an output pin. It is an output pin. That is, it gets an output from the this sensor HR04 sensor. So this HCSR04 sensor accepts only 5 volts. So that's why I'm converting this 5 volt into a 3 volt. How to do this is use a 1K and 1.5K resistor. So see here, in series I have connected it. Again I'm adding one. This is 1K resistor. Again I'm adding one more 1.5K. From this I'm taking an output and I'm connecting it to this. What is this pin? 38th pin. So it should also be a GPIO pin. So this trigger is an input pin. This my echo is an output pin. Okay, please understand this. Let me check out what is 38th pin is. So it should be, yeah, it is also GPIO pin. It is 20 and 21. Okay, are you getting this, guys? The flow of this?
Yes, sir.
Yeah, yeah. Do you want me to repeat this connection or are you clear? Are you clear? What is VCC? What is
Yes, sir.
trigger?
Got, sir.
Yeah. Okay. Next, let me go through the flow of this Python program. So whatever I have explained, I have put it as a Python program. I have done some modification. Okay. So this library you have to this Word file is visible to you. Yes. You have to import this library, that is rpio.gpio, that I'm keeping it as gpio. I'm going to use this library as with the variable gpio. Okay, by default import the system time, so it should need the exact time. So I told you trigger is an input pin, so it is 21. So I'm mentioning it as 21. Actually it is connected to which trigger pin? It is connected to pin number 40. Okay, in GPIO. Eco pin is your output pin. It is connected to pin number 38, which is GPIO pin 20. Okay, now I'm, yeah, are you getting this, guys? Why it is 21 and 20? You have to specify the exact number while programming. Now this I'm setting this my GPIO pin mode to HCI SR04 board. to to transfer these data. Now I'm using a while loop. Now what I'm doing here is this trigger I'm setting is it as the output pin. So what is the output pin of trigger? It is 21. Okay. Then echo I'm setting it as the input pin. So it should be 20. So 20 will be copied here and 21 will be copied to your trigger. Okay. Then initially what I'm doing is initially I'm when connecting the device your Raspberry Pi device with your HCSR04 sensor, it should be in false state. Okay, immediately it should not go to um, your positive state. So you will not get accurate output. So I'm keeping it as low. Low means false. Okay, or you can specify LOW or you can specify 0. So how many seconds I'm keeping it? For zero point 0.2 microseconds I'm keeping it. Okay, then now I'm raising the trigger pin to 1. So that means a positive pulse is created. Okay, we are generating this through our program. Through our program, we are triggering that input. So this trigger, how many seconds it is taking? It is 0.001 microseconds. Okay, so now what I'm doing after 1 seconds, it will again go down to low condition. This trigger. Okay, now I'm writing while loop for this echo. Okay, when this trigger rises up, I'm initializing this echo to 0. Please understand, when this trigger is high, this echo should be in 0 condition. At that time, what you should do, you should get the time option. Time is nothing but it's an echo time. That means it takes time from the it takes time or generates time for each and every microseconds accurately. Okay, so it's an interesting function in Python. It is used to generate your time in an accurate way. So I've used this function time. Next is when the trigger becomes false, what I should do? No, I should raise the echo. That is what I have done. So this is my transmission part and this is my receiver part. Please understand, this is my transmitter part. At this time I will calculate the time here. When when the sound waves reaches the obstacle, this line will get executed. Once it bounces back from the obstacle, this line will get executed. Okay, so 2 times I'm capturing the time. Okay, please understand how it is being related. Now what I do is you have to calculate the exact duration. Okay, so I have captured 2 times, right? You have to calculate the exact duration. How to calculate it is this pulse start indicates the distance from or the time from your transmitter to the obstacle. This indicates the distance from your obstacle to the receiver. So both these things should be minus to find the exact distance. That is pulse end minus pulse start. We got the exact duration here. Now you have to calculate the duration means speed. Now we have to calculate the distance. How to calculate the distance? It is the speed into this. I told you. Okay, what is the value? It is 17150. Okay, after doing this, calculating the distance, I'm rounding it off. You can I am using just a round function to get an accurate result. That's all. After that, I'm printing the distance. Am I clear with the logic? Are you getting this, guys?
Yes, sir. But what's that 17150, sir?
Yeah, I told you, no. Here, see here, speed of the sound per second. When you use this sensor, it is 34400 centimeter per second. Okay, you have to divide it by 2. Okay, so I got this 17150. I told this, right? Do you remember?
Okay, sir.
Yeah. Now you are clear. What is this 1750? It is the speed of the sound when you use this sensor. Am I clear with the logic, guys? Are you getting this?
Yes, sir.
Okay. So now, okay. So, yeah. So, can you see this connection, right? Yes,
Yes,
guys.
sir.
Okay, I will tilt it and show it you. This is my connection. You can do it. It will take just 5 minutes to do this. I've connected everything correctly. Okay, I've used the resistors also. Please, I'll show it in close to you. See here, the resistors is 1K, next one is your 1.5K. So this connection also I've done it with my Raspberry Pi. This is how it's done. So the pin numbers I've used is what are the pin numbers I used? So I've used 4 and 6, then 38 and 40. 4, 6 and 38 and 40. So fourth is my 5-volt pin, 6 is my ground, 38 is my GPIO 21, and 40 is my GPIO 20. Are you getting this? Can you see this? How this connection is done in Raspberry Pi? So at the top, I have this. At the bottom, I have this blue and green wires. At the top, I have this rose and gray color wires. So this blue indicates your 40th pin, green jumper wire 38th pin. My rose is my ground, and gray is my rose is my volt pin, and my gray is your ground pin. Okay, this is what my connection as of now. So let me connect this. Let's check whether it's working fine. We have to check. Okay. See, I'm using a monitor. Okay. So through VNC viewer, I'm accessing my laptop monitor as well as my nearby monitor, so that if anything goes wrong, no, I can easily find it out. What is my IP today? It is 137. Okay, it remains the same like yesterday. So let me use my VNC viewer to open this Raspberry Pi. So from laptop, I'm opening my VNC viewer. From laptop, I'm using my VNC viewer. You have to type the IP address of the Raspberry Pi. It is 137.73. So it's taking the yesterday's IP. So give enter. It will ask for username and password. Give it as Pi and Raspberry. Yeah, this terminal is clear for you guys. Yes. Guys.
No, sir.
Just a second. Yeah. This is visible to you? Raspberry Pi terminal?
Yes, sir.
Yes, sir.
Okay. So I've written the program already. Okay. I have kept it as ultra.py. I think so. Sudo nano ultra.py. Yeah. I tried 2 to 3 programs. Yeah, this is fine. So I've just the same program. So trigger pin is 21, which is the input we should supply as a positive pulse. Then echo pin is 20, which is the output we get it back from the sensor. So this everything is fine, right? Yeah. So the same logic I've explained you. I've used the same program out here. So let me run this program and check whether it is working fine today. Yeah, it is working fine. So it is saying, so now what should I do is I should see here distance. Now I'm moving it a bit. See here, uh, guys. Yeah, yeah. Can you see this? Yes.
Yes, sir.
See, now I'm bringing my hand closer. See, it is getting reduced. Can you see the difference in the screen?
Yes.
Now
Yes, sir.
now I'm moving my hand away from there. See here, the distance is getting increased. Can you see this?
Yes, sir.
Yes, sir.
Okay. Can you see this? See, yeah. Let me show it.
Yes, sir.
Yeah. See here. I'm bringing it closer. The distance is getting reduced. So I'm taking it away from my thing. So it is getting increased. So how far it is good? How far it is good? How much centimeter it will cover? It will work fine. What is the thing I told you? So it is good up to 4 centimeters. That's what they're saying. Okay. So what is the major purpose of this ultrasonic sensor is? It is used to find an obstacle which is in front of the sensor. So it is used in your traveling applications, okay, to find out any obstacle. Like whenever an animal roam in front of the in front of your car, you can use the sensor to identify the same. Okay, but how does it operate? It operates using ultrasonic waves. Okay, it operates using ultrasonic waves. So they're saying it's more accurate since it contains both transmitter and receiver part. So it is okay. Yeah, can you understand this, guys?
Yes, sir.
Okay. Yeah, I'll unplug that. Yeah.